in problem 39, notice it says a sample of a substance with an initial mass of 963 grams is decaying at a rate of 27% per hour. Create a function that can be used to find y, the mass of the substance in grams, after remaining for x hours. Enter your answer into the space provided. Well, let's take a look at what we know. So this said the word decaying, right? And anytime you see that something's decaying or it's growing, then you should be thinking exponential growth and decay. Now we have to go back to our formula that we have. Our formula is f of x is equal to a, which is our initial value, times b, which is going to be our growth or decay factor, to the power of x. So I'm going to go ahead and write some notes right here. Go ahead and write this down. So a is going to be your initial value. We also refer to that as our y-intercept because it's our starting point. It is always where we start. B can be one of two things. If it says it's growing, it's exponential growth, and the way we find B is we do 1 plus r, which is the rate that it changes. Or if it's decay, and in this case it said decaying, so it's going to be exponential decay, we find it by using 1 minus r, the rate. So with this information, let's go ahead and create our equation. So my equation for this is going to be f of x is equal to, they said my initial mass was 963. So for A, I'm going to write 963. And then for my B, since it said decaying, I'm going to do 1 minus, and the rate they gave me was 27%. So I'm going to go ahead and put 27 and put a decimal percent. Now you can do it all at once like this, or if you want to, you could go ahead and convert the 27% and then subtract, take 1 minus whatever that value is. So I'm going to go ahead and I'm just going to write it out just like this, and we're going to go ahead and throw it in the calculator and see what we get. And remember, this is all to the power of x. I'm using an x for the time because that's what it said in the story. It says it wants to find out the mass of the substance in grams remaining after x hours. So let me go ahead and I'm going to simplify this part right here, right? In other words, the decay factor. I'm going to simplify it. So I'm going to go home real quick. I'm going to go up to calculate, and to find my decay factor, I'm going to go ahead and do 1 minus 27, because it's 27%, put a decimal after it because it did not have a decimal. I'm going to hit my question mark until I get to the percent, hit enter, enter again, and it's 0.73. So when I rewrite my final equation is going to be f of x is equal to 963 parenthesis, and for the b I'm going to put 0.73 to the power of x. Now this would be the function that I would use to find that amount of decay if they were to give me some time. Right, so they didn't give us the time, they want us to just create the equation. So we're going to type it in just like you see here. So it says put it below. So I'm going to go ahead and go down here. Now remember, in place of f of x, we can always use y. So you can write this out actually as y is equal to 963. 0.73 to the power of x. So I'm going to put this in because they have a y here. I don't see an f and x. That's not an option here, but we can definitely put a y. So y is equal to 0.73. So I am going to put a parenthesis. Let's see, do they have parentheses? They do have parentheses. So I'm going to put 963 first. And then I'm going to put my parentheses. And I'm going to put 0.73. And I'm going to close parenthesis. And then we need to put to the power of x. So notice over here, it looks like we have, I'm looking for a caret key. It doesn't have a caret key, but we do have this little power button here. So I'm going to click the little box right here. Notice it has a small box right at the top and a larger box at the bottom. And I'm going to put my power of x in there. And it did, it worked out. So that's how you do it. Y equals 963, parentheses 0.73, close parenthesis, to the power of x. And that is the correct answer. Go ahead and pause this video and see if you can figure out number 40 on your own. And number 40, notice it says, which graph best represents the solution set of 3x is less than 2y plus 6? Now what I'm going to tell you is the first thing, when you get one of these inequalities, I am going to write this out. So I have 3x is less than 2y plus 6. And the first thing I really want you to focus on when you get one like this is I want you to look at this symbol right here. And I want you to remember the type of line you make for that. Anytime you have a symbol like this, you have a less than or a greater than symbol. If you were to graph this, it must use a dashed line. So I'm going to write dashed line. So just remember that, right? Because we can rule out some answers with that. Now, in contrast to the less than or greater than, if it were to be like this, less than or equal to, or greater than or equal to, well then we're going to have a different scenario. For instance, if I were to draw graph 1 that is less than or equal to or greater than or equal to, we should have a solid line. So it would just look like your typical graph because it can touch it. This one is dash because less than or greater than means it can never touch it, but it can come really close. The next thing that I would recommend that you do after figuring out that symbol and looking at it, you can see I'm just highlighting the symbol. It was a less than, so we should have dashed answers. So let's cancel out any answers that don't have a dashed line because they're all going to be wrong. So I'm going to go to strike through. Let's go down. See, this one's got a solid line, so that one's wrong. And this one's got a solid line, so that one's wrong. So now you got a 50-50 chance of getting it right. It's either going to be C or it's going to be A. And if you look at it, they look like the same line. The only difference is on A, the right side is shaded, and on C, the left side is shaded. So we just got to figure out, do we shade the left or do we shade the right? The best thing to do here is to pick my favorite point. And I really hope that you remember, I'm going to write right here, Mr. H's favorite point. Now my favorite point to use for this is going to be, you guessed it, 1, 1. And that's because they're both the same number. That's my x value, that's my y value. And all I'm going to do is substitute the x value into my equation for this x after the 3, which is 1. And then I'm going to substitute my y value of 1 in place of the y that comes after the 2. In other words, if I were to write this out, I would have this. I would have 3, and then instead of an x, I'm going to put my x value in parentheses of 1, and then we would have is less than 2, and then we're going to put our y value of 1 in place of the y, and then we're going to have plus 6. So notice it looks just like this right here up at the top, but all we did is we replaced the x and we replaced the y with a 1 and a 1. Now what I need you to remember is if this happens to say true, if you look at the graph, 1, 1 and A is not shaded. So if this is true, 1, 1 must be shaded. If it is false, 1, 1 must not be shaded. So I'm going to write that on there. I'm going to say if true, shade 1, 1. And then I'm going to say if false, shade opposite side. All right. So we're looking to see, is it going to be true, where 1's got to be shaded, or is it going to be false, where it's not shaded? So let's put it in the calculator and find out. So I'm going to get my calculator. I'm going to type this inequality in. So you just go to calculate, and then you put the equation straight in. So 3, but instead of an x, I'm going to put a parenthesis and put a 1 in place of x. I'm going to hit Control equal to get my inequality symbols. And I'm going to pick my less than symbol because we want it to look just like the inequality they gave us at the top of the graph. And then it says 2 times y. But instead of a y, I'm going to put parentheses and put my y value of 1. And go ahead and close the parenthesis and then put plus 6. Hit enter and notice it says true. Because it says true, then that means 1 must be shaded. So that's the one that's going to get the shading, is the 1. So let's look at it. A does not have 0.11 shaded. Notice A, it is unshaded. So it can't be A. And if I go down to C, C actually has 1 in the shaded area. So I know that C is the correct answer. Go ahead and pause this video and try to do the next one on your own. In problem 41, notice it says, what is the slope of a line that passes through points 10, 18, and -5 and -12? Okay, well my first ordered pair is 10 and 18. And my second ordered pair is -5 and -12. Now there's two ways you can do this. You could use the slope formula. And if you forgot what that was, it is actually on your formula sheet. Let me show you right quick. If you get this formula sheet right here, and I move this up and I go to linear equations, notice it says slope of a line. And this is your formula to find the slope of a line. y2 minus y1 over x2 minus x1. So we could definitely do that. So m is equal to y2 minus y1 over x2 minus x1. And you would just have to label your ordered pairs, right? For instance, 10 and 18, you might call this x1, y1, and then the second order pair would be x2, y2. And you substitute those values in place of those letters. Now the easiest way to do it, and the way that I'm actually going to do it right now, is I'm going to go ahead and use spreadsheet. But spreadsheet is very useful. It's also going to find the slope for us. And so let's do menu. And then after you do menu, data, and then menu. And then you do 4, 6, and 1. So I'm going to show you how we can use both of these. I'm going to do spreadsheet first, and then I'm going to go ahead and use the slope formula so that you can see it done both ways. So I'm going to get my spreadsheet real quick. I'm going to go home and go over to spreadsheet, hit enter. I want to change this X. I want to get rid of all my, notice I got way too many spreadsheets open. So I want to click that, hit no, I don't want to save it, go back in, change A to X and B to Y. And I'm going to put my ordered pairs in. Now first we had 10 and 18. So 10 for X, 18 for Y. And then we had -5 and -12. So -5 for X and -12 for Y. Now once we got that done, we're going to go home, go over to data, hit enter. I'm going to go down and change this horizontal axis to X. I'm going to change the vertical axis on the left to Y. And then hit menu, 4, analyze, 6 for regression, and 1, show linear mx plus b. And there's my equation. So I'm going to write it down. So I have y is equal to 2x minus 2. And remember the first number here, that is my m, which is my slope, which we also call our rate of change. So my answer is positive 2. So I can go over to B, click on it. That is the correct answer. But I just want to show you, for those who may not like using spreadsheet, I want to show you how simple it could have been to just go ahead and use the slope formula as well. So let's look at the slope formula. I'm going to go ahead and just rewrite it. Instead of a y2, I'm going to go ahead and put some parentheses for it, minus another set of parentheses, over my x values, my x2 minus my x1. And notice they give us two ordered pairs. I'm just actually going to write them right here. So we had the first ordered pair was 10 and 18. And the second ordered pair was -5 and -12. So what I would do is, if I wanted to use these, I would just call this one x, and I'd call this one x2. So that's my x1, that's my x2. For my y's, that's my y1, that's my y2. And then I would substitute these numbers in place of the letters. So instead of y2, I put my y2 value, which is -12. And then I put my y1 value, which is 18. And for the x's, I put my x2 value, which is -5. And then my x1 value, which is 10. Now I'm ready to put this in a calculator, and it would actually give me the answer. Now, I feel like when the formula is useful is if you want to definitely get your answer in a fraction form, because it'll give you the fraction. On the other hand, if you use spreadsheet, it's always going to give you the slope in decimal form. So let me put this in. I'm going to hit Control Divide to get my fraction bar, and I'm going to put these numbers in just like you see them. So parenthesis, -12, close parenthesis, minus parenthesis, 18, close parenthesis, and then on the denominator, I'm going to put parenthesis, -5, close parenthesis, minus parenthesis, 10, close parenthesis. Hit enter, and it tells me that it's 2. So you can either use the slope formula or you can use spreadsheet. I would say use the one that you feel is easiest to use. I'm going to go ahead and pause the video now, try to do number 42 on your own, and then resume the video. On problem number 42, notice it says, what are the solutions to the equation x squared minus 2 is equal to -3x? So it wants us to find the solution to it, which means we're going to have to solve this quadratic. Now there's more than one way we can do it. We could solve this by completing a square, which I think is the most difficult way. We could use the quadratic formula, which is pretty straightforward and easy. You just have to substitute numbers. Or we could solve this by graphing. Now with the graphing, we do have to do a little extra work, but it's not too much. So I'm going to start with graphing. So I'm going to write it down, solve by graphing. Now if we wanted to do that, first we'd want to go ahead and write this. So we're going to do x squared minus 2 is equal to -3x. Now we need it, in order to solve this, we actually need to have it in this form. I'm going to put a x squared plus b x plus c. So notice right now it's not in this form. The middle term has been moved over to the right. So the first thing I want to do is move that middle term back over to the left. So we're going to add it over here. So that cancels, and if I were to rewrite this, I would end up having x squared plus 3x minus 2. So notice I just brought that down there, brought this down here. So we didn't put anything together, right? They're different terms, we can't combine them. But I have them all written here. So now I can actually graph that, and I can find my zeros. So I'm going to go ahead and get my calculator. I'm going to click home. I'm going to go to the home, and then I'm going to go down to my favorite graphing feature, add graphs. Click on that parabola. And I'm going to type this in. So I have x squared plus 3x minus 2. Okay, there it is. Look, we can actually see our zeros. To me, it looks like it's a little bit less than 1. And we have one that's over here. It looks like 1, 2, 3, between -3 and -4. So what I'm going to do is actually going to find the zeros. I'm going to hit Menu. I'm going to go down to Analyze Graph. and I'm going to click on 0. Now, the only downside to this is it will not give the 0 as an exact number. And if you're wondering, well, Mr. H, what do you mean by exact number? What I mean by exact number is that it doesn't have a radical in it. So if you notice, look at two of these answer choices. They have a radical in them. Do you see that? There's 3 plus or minus square root of 17 over 2, negative 3 plus or minus square root of 17 over 2. So when we see these two types of answers, those are exact answers because they're written as a radical. And I'm looking at this. This is a decimal. Now, one thing that we can say for certain already, just by looking at the first one. With the first one, my 0 is negative 3.56. Because that's one of my zeros, I can automatically strike out B and D because they're made up of integers, right? So we can go ahead and get rid of that. And we know it's either got to be A or it's got to be C. Now I'm going to go ahead and check my second one real quick. So I got menu, analyze graph. I'm going to go to 0. And there's the second one. Now, I'm going to write these two zeros down so that I know what I'm looking for. And I know that for the first one, I'm going to put x equals negative 3.56. Negative 3.56. And I know for the second 0, I have 0.562. And it's positive. So that doesn't really help me that much, right? Because one is positive, one's negative. So it's hard to tell which one it might be. But what I am going to do is go ahead and convert those answer choices that you see up here into a decimal. I'm going to go home, go to calculate, and I'm going to go ahead and hit Control Divide to get a fraction bar. And we're going to do the first one. Notice it says 3 plus or minus. Now you can't do plus or minus at the same time in the calculator, but you can do them one at a time. So I'm going to start out by doing 3. And then I'm going to hit plus the square root of 17, so control x squared, 17. And then in the denominator, I'm going to put my 2, and I'm going to go ahead and put a decimal after it, and I'm going to hit enter, and it'll convert it to a decimal. And notice it gives me 3.56155. And notice we had right here, our calculator said 3.56. So to me, this looks like the answer. This would be correct. The positive one, that is definitely one of our answers. Notice there is a positive and there's a negative. So I see this positive 3.5 and I said, well, that looks like it might be it because it's 3.5. Now this says negative. So then my thoughts are, well, let me put the minus sign in here and see if I end up getting a negative one. Now if I don't, then it's not the correct answer. But if I do, then it would be the correct answer. So let's give it a shot. So I'm going to put it in. So control divide 3 minus the square root of 17 over 2. Put a decimal, hit enter. And notice it gives me negative 0.561553. So while I do have a 0.56 here, it's not negative, it's positive. So what they've done here is they've switched the answers. Notice, right, when I need it to be negative, it's really positive. And when I need it to be positive, it's really negative. So I'm going to go ahead and cross that one out. That is not going to be the answer. And now I'm going to go to the next one. Now if we check this last one, we're going to check C, and I'm going to use the same method. So I'm going to go ahead, hit Control Divide, and I'm going to put in negative 3 plus the square root of 17 over 2, put a decimal, and it gives me positive 0.561553. And this is 0.562. So right now we're looking good. I got my positive value. So now we're going to go ahead and put it in again. We have negative 3, and this time we're going to do minus the square root of 17 over 2, put a decimal, and notice it gives me negative 3.6 or 3.56. So that is it. So C is the correct answer. Now just in case you wanted to see a different way to do it, if you're happy with this and you don't mind doing it this way, this looks great to you, you can go ahead and pause the video and move on to the next problem. But if you want to see a second way you could have done it, just go ahead and continue watching this video, and I'm going to show you now how we could have done it using the quadratic formula. Now one thing I want to mention is when it comes to the quadratic formula, I'm going to write it right here, quadratic formula. That equation, you don't have to memorize it. It is on your formula chart for the STAAR test. So notice it even says it's the quadratic formula. So we're going to write this down real quick. So let's write it down. So I end up having x is equal to negative b plus or minus the square root of b squared minus 4a and c. And this is all over 2 times a. Now I'm going to go ahead and I'm going to use this formula to solve it real quick. So let me go ahead and put x is equal to negative, but instead of a b, I'm going to put parentheses for it because we're going to replace that b with our b value. And we got plus or minus. And even though I'm putting the plus and minus, we'll do these one at a time. The square root of b squared, so I'll put that number in there again, minus 4 times our a value times our c value. So now that I've got this on there, I'm going to divide all of this by 2 times whatever our a value is. So I'm going to circle the letters as I replace them. So the first one we're going to replace is the b. We're going to put that in this spot. So if I go back up here, notice I still would have had to convert it. I still had to move the 3x over to do it this way too. My b value is a positive 3. So I'm going to put a 3 in there. This second one is also a b value, so I'll put a positive 3 in there. And then I need to replace the a value. Okay, my a value, in this case, it's of an invisible 1. So I'm going to put a 1 right there. And then my c value, that's my constant. It happens to be negative 2. So I'm going to put a negative 2 in there. And then my a value, once again, down here at the bottom is going to be a 1. So we put it in here, right? And I'm going to show you how to get an exact answer. Now we could put this in the calculator. In other words, I could actually take the calculator and I could have put this all in. I'm going to show you. We're going to do it. So I'm going to hit Control Divide. And I'm going to put in negative parenthesis 3 close parenthesis plus, because I'm going to do the plus one first, square root of b, which is 3 again, squared minus 4 times a, which was 1, times c, which was negative 2, over 2 times a. Alright, so you can see all this right here, the way that it's written, is in my calculator the exact same way. So I'm just going to hit enter. And it still gave me the positive 0.562. Then I could go back up to it, highlight it, hit enter, bring it back down, and I can go and change this plus sign into a minus sign. And it gives me the negative 3.56, which is what we have here. So you can see you could have used this to do it. Now if you want to get an exact number to where you can actually see this radical right here, you would have to do it by hand. Right, and if I were doing this by hand, let's say that I decided to do the positive first, I would end up having negative 3 plus the square root of, and I'd have 3 squared, which is going to be 9, minus 4 times 1, so that'd be negative 4, times negative 2, that would turn into a positive 8. So positive 8, draw my line, and 2 times 1 is 2. So if I were to continue to write this, I would end up with negative 3 plus the square root of, and 8 plus 9 is 17, over 2. And this would have let me know that this negative 3 plus square root of 17 over 2 is the correct answer. So again, this is doing it by hand, right? But we could also do it with a calculator. And we could also do it by just simply taking this and graphing it and finding our zeros. Or you could use the complete the square method. Use the one that you feel you're most comfortable with, that you felt was easiest in this video. And go ahead, pause the video now that you know the correct answer, and move on to problem number 43. In this problem, notice it says in the expression shown, x is a value where the expression is defined. And it says, what is the simplest form of the expression? Write your answer in the form of ax to the power of b. Enter your answer into the box provided. So when we get done, we want our answer to look like ax to the power of b. Because of that, we are going to have to use our exponent rules. Now remember, right, we have 4 different rules. We have the product rule, which says when multiplying exponents, we add powers. We have the quotient rule, which is where we're dividing exponents, and if that happens, we subtract the powers. We have the power to a power rule, which says when we have a power and we're distributing it to a power, we multiply the powers. And then we have our zero rule, where zero exponents, anything to the power of 0 is equal to 1. And we have our negative exponent rule, which means that if I have an exponent, let's say I have x to the negative 3 power, that if I want to change that to a positive, all I have to do is move it down as a denominator and leave the coefficient of 1 up as the numerator. And this becomes a positive power now, 1 to the power of x3. If I want to change it back negative, I just move it back up to the top. So those are our rules. So let's use them to go ahead and solve this. Now I'm going to write this out. We have 2x to the power of 8, close parenthesis, another parenthesis, and then we have 3x to the power of negative 1, close parenthesis, to the power of 2. Now there are a couple things going on here, and I know in the past if we didn't have this power of 2, we could just put dots in between these terms and we would start combining powers and go from there, and it'd be really straightforward. But because we have a power on the outside of a parenthesis, we actually have to distribute this power both to the x, its power, and we have to distribute it to the 3 to the power of 1. So we must do the exponent first before we can start multiplying things out. Now if I do that, remember that this 3 has a power of 1. So what I really have is 3 to the power of 1 times this outside power of 2. And then I have an x. So this is going to be times x to the power of negative 1 times this outside power of 2. So notice this power of 2, I just took it and multiplied it to that power and multiplied it to the power of 3, right? This 3 has a power of 1. So now what I'm going to do is I'm going to multiply this out. I know 1 times 2 is 2. That one is really easy. So I got 3 to the power of 2. Negative 1 times 2 is going to be to the power of negative 2. So that becomes times x to the power of negative 2. And so we finished handling this distributive property here. So now let's bring this one down. And when we bring this down, we can actually keep it really simple. We can write a 2, put a dot in between it and the x just to remind us that it's actually just being multiplied. And this x is just being multiplied to that 3. Now before I start putting things together, I want to go ahead and I want to take care of this power of 2 here, because I can actually put that in a calculator, 3 to the power of 2. And I can get a number for that. So let me do that right quick. I'm going to go to calculate, and 3 to the power of 2 gives me 9. So this 3 to the power of 2 actually becomes a 9. Bring down my 2, my x to the 8, and bring down my x to the negative 2. So now we're just dealing with numbers. And remember, the order in which we multiply doesn't matter. So I'm going to try to keep things simple. I'm going to deal with the numbers first because I feel like that's always the easiest to deal with. I'm going to circle them. I am going to be multiplying 9 times 2. And when I multiply 9 times 2, 2 times 9 is going to give me 18. So we're getting closer to being done. Got rid of the 2 and the 9. Now I'm going to multiply the x to the 8th power times x to the negative 2 power. Now remember, so far what we've done, when we started here, we used the power rule, right? So that's how we multiplied the powers, the 2 times the negative 1 and 2 times the power of 1 for the 3, right? Because there's an invisible 1 right here. Next, once we got to this point here, these are just all being multiplied, which means it's the product rule that we use. And that means we just add the powers. So I'm going to take this x, I'm going to start off with the x to the 8th power. So x to the power of 8, I'm going to box it, and I'm going to combine it with x to the power of negative 2. So I'm going to add it plus, and then negative 2. So I'm adding this power for the second x to the power of the first x. The negative 2 is getting added to the 8. I'm going to put that in my calculator, right? Anytime we deal with integers like that where we have positive and negative, I would go ahead and just use the calculator to calculate it. So 8 plus negative 2. And that gives me a positive 6. So my final answer here is, this is going to be 18 x to the power of 6. And that is my final answer. This is simplified. We have done all the multiplication with the numbers to get a final answer, and we have went ahead and combined similar bases by adding their powers. So we'll type in 18. I'll put my x to the power of 6. And that's my final answer. Go ahead and pause this video and try to do number 44. Problem number 44 says the table represents some points on the graph of a linear function. Which function represents this relationship? And I know when you're looking at this, you're probably thinking this looks like a nightmare. We have all these fractions. And I agree, fractions are tough to deal with sometimes. However, I think the easiest way to do this is just to go straight to spreadsheet. Honestly, I wouldn't do it any other way. So I'm going to go ahead and I'm going to write spreadsheet right here. And once we go to spreadsheet and enter our data, we're going to go to the data page, and then we're going to go to menu. And since it said it was linear, we're going to do 4, 6, 1 to get our linear regression, which is going to give us our equation. And our equation, right, we have y is equal to m, which is our slope or rate of change, x plus b. And we'll write it out. Now it's not going to give it to us in fraction form. It's actually going to give it to us as a decimal, but that's all right. We'll convert our answer choices to decimals and see which one actually matches up. So let me go ahead and get my calculator and we're going to get started. So I'm going to place my calculator right over here. And I'm going to go home. And go down to spreadsheet right in the middle. Now I do have multiple spreadsheets open from the other problems we did. So I'm going to go to it. I'm going to click on it and put no, I don't want to save it. Because we're going to start new with a fresh spreadsheet. Now I'm going to go ahead and change A to X. I'm going to change B to Y. And I'm going to enter all my X values in first. So notice I have -1, 3, 6, and 10. So -1, 3, 6, and 10. And for my Y values, I have 27 over 7. Put my fraction bar. And my next one is 11 over 7. And the next one is -1 over 7. And the last one is -17 over 7. So notice it didn't let me put my fraction bar in. When I click down, it just changes it to a regular division symbol, right? So at this point, what I'm going to do is I'm going to go ahead and click home because I clicked out of my last entry. I'm going to go to data, hit enter, change this bottom axis to X, change the vertical one on the left to Y, and then menu 4 for analyze, 6 for regression, and 1 for show linear and mx plus b. Alright, so I have kind of a really crazy looking, and this explains why they used fractions, right? Because you have these really long decimal strands. Now I am going to write this whole equation out on my paper before we start doing any conversions. So I'm going to round it. So we have -0.57. So -0.57. And the y-intercept is plus 3.28. So all I did was just round it, right? Because we want to get close. And I'm going to start converting the fractions and see which ones actually make sense. Now I noticed that I do have a negative slope, right? The -0.57 that I rounded, it's -0.571429. Because that slope is negative, I already see I can cancel out two answer choices. So let me show you what I mean. If I go over here real quick and I go to this strike through and I go down, Notice this has a positive slope, C has a positive slope, and D has a positive slope. So we got a 50-50 chance of getting it right now because we can cancel those out. It can't be C or D because we have a negative slope. Now it either has to be A or it has to be B. So I'm going to go ahead. I notice they got the same slope. The only thing that's different is the y-intercept. So I'm going to go ahead and just confirm that negative 4 over 7 is negative 0.57. So I'm going to go back home, go to calculate, hit Control Divide to get my fraction bar, and I'm going to do negative 4 over 7, put a decimal after it, and notice it does give me negative 0.57, which is what we have. So that's good. So now we just need to see which one of those fractions, the 23 over 7 or the 31 over 7 for B, which one of those fractions is actually this y-intercept. So I'm going to try A first. So Control Divide, we have 23 over 7, put a decimal, and that gives me 3.28. And notice that's what I have. So I'm thinking at this point A is going to be the correct answer. But let's just check B so we can see what it comes out to be. If we check B, we have 31 over 7, put a decimal, and that gives me 4.4. So B is incorrect. A is the correct answer. Go ahead and pause this video and go to 45.